So, next part after we do the modeling of exponential, next we need to learn the friend. Okay, this Pure One chapter 14.4, Intro to Logarithms. Okay, the friend of exponential, which is logarithm. Actually, enemy, would it be enemy? Yeah, actually, it would be the enemy. You will see why. So, do you ever wonder how to work out these questions apart from trial and error? I'll let you have a go. Okay, put in the calculator, try and error, work out the value of x. See if you work it out in 10 seconds. I'm not going to pause for 10 seconds. So, if you try it, you should get x equals to 16 for the first one. Yep, 16. And the second one should be 12. So if you got it right, if you guess it correctly, okay, you both try and error, you should get x equals 16, x equals 12, right? But obviously, we can't always run try and error, and we know that's not really mathematical. Um, this skill is more like a science skill, where science you prove it by try and error. But in maths, that's why there's a difference between theory and theorem. In science, you heard about theories because they are weighted to be disproved. So they do a bit of try and error experiment. It's all about experiment. They work. It works for different times. It works for if you've got a theory and it's worked for them so far, but waited for them to be disproved. Whereas a theorem is proved by logic, where you can't disprove it. Okay, so that's the difference. In maths, it's theorem, Pythagoras theorem. In science, Big Bang theory. Right. You also get different theorem in maths, but you just haven't learned it yet. For example, Fermat's last theorem, which you'll learn it in university for math, university maths, something. So here, the inverse of exponential function is logarithms. That's the opposite. Okay. So if we have ac to the power of b, then log log base a of b equals c. Now note the font size of a is actually a lot is smaller than b, and it's actually positioned at the bottom right corner of the log. So it's positioned slightly lower than the normal line of writing. So this is called the base. So this is the base. So this is the base a. Okay, equals c. So for example, e.g. in here, you've got 2 to the power of x equals 65536, right? If you heard me put in calculator just now in the start of the question, you might be wondering how to do that. That's what I did. So log, okay, try to use it, log. So a means the base is 2 of 65536. You can put in a calculator. Let me show you. So you see this button here, okay, log, okay, you can put in base 2, 65536 is 16. So 16. Okay, so that's the answer. So x equal, sorry, x equal. Um, so one more bullet point. By default, log has base 10. That means, for example, if you're given log 5 without anything, it means that's the same as log base 10 of 5. It's like in algebra. We write, we don't write 1x, we just write x. Same thing with log, okay? Log 5 is the same as log base 10 is 5. Okay, so what's the relationship of A and B? You'll be thinking here. The ratio of A and B is that how many powers of A to reach B. So right in here. Okay, so what's the sort of the connection between A and B? So you'd be thinking about how many power of A to reach B. So for example, in here is 2, how many power of 2 makes you to reach 65536. That's sort of the ratio between log the base and the number here. Okay. Right. So in here, we're just going to do a bit of simple exercise on how we can get used to exponential functions using logarithms. So example, we write the following using logarithms. So 4 to the power of 12 equals, how do you read this number? Okay, 16,777,216. So question A, what we can do is, so if you compare the previous, Okay. Log 2, 65536, we can rewrite as 2 to the power of x equals 65536. So in here, what it means is we can write log base 4 of 16777 to 16, and that equals to 12. Okay. So a to the power of c equals b. Therefore, log base a of b equals c. So that's the rule we'll be using. Okay. Part b. A to the power of c equals b. So log base 0.3 of 0.0081 log ab equal c. All right. What about the other way around? Okay, we write it using a power. So log ab equals c. So log ab equals c. A to the power of c equals b. Part b. Same thing. A to the power of c equals b. And that's it. So your turn. Okay, pause the video, have a go rewrite them. Okay, using either side of the logarithms. If you're given left side, write the right side. If you give the right side, write the left side. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Okay, quite straightforwardly. If you put in a calculator left hand side, put in a calculator, you should get the right hand side value. Okay, right, moving on. To solve equations with logarithms, okay, simple ones, what we can do is we can use the law we just learned, okay? Rewrite that again. A to the power of c equals b, log ab equals c. We can't solve log function, but if we can use this law to help us to get rid of log, use this rule to get rid of log, then it's solvable. So log ab equals c, okay, so question A. Okay, so let me write down. So log 7 x equals 1. So that's your log a b equals c. Therefore, a to the power of c equals b. So x equals 7. Question B, same thing. Okay, log a b equals c. A to the power of c equals b. So 3 to the power of 4, put in the calculator. That should give you 81 if my mental math doesn't fail me. Yep. So 81 equals 4x plus 1 minus 1 is 80 divided by 4x is 20. Okay, your turn. Pause the video, have a go. Press question 2. When you're ready for the answer, you can press play. Here are the answers. Okay, so 2 to the power of 3 equals x minus 1. A hopefully should be quite straightforward. Part B. So x squared equals 2x. When you say quadratic, again, do not divide x on both sides. So bring to the left-hand side and factorize it. But x equals 0 is not a valid answer. You don't have to explain why. If I tell you why, because the base cannot be 0 when you log it. When log, in log, not when log, English, my bad, pardon, in log. Okay, that's why you can't have x equals 0. Right? Any more? Nope. And that's it, ready. Okay? And that's the end of chapter 14.4, a bit of intro. Next lesson, we'll dive into more laws about logarithms.